Alright, welcome back to geometry. This is section 1.3, and in this section we're going to spend some time just talking about geometric notation and how to name some geometric figures. So the learning goal for this section is to just be able to use the correct notation to name geometric figures, and then we're also going to look at kind of doing the opposite of that. So given a description or given the notation, we're going to be able to draw and create these accurate diagrams representing them. So let's go ahead and just start by naming points and lines. We know that points are just locations in space that do not have any actual size. And we've briefly touched on this before, but the way we name this is just by using a capital letter. And so as you recall, a point just looks like a dot, and you can choose any capital letter you want for its name. And so now we can just refer to this point as point A. And so our next term that we've seen is a line. If you recall, a line is just a set of points that extends forever in two directions. And the key thing we got to remember when we draw a diagram of a line is that you have to include the arrows on the end to show that it keeps going on forever. Now, there's two ways that we can name lines. We could always just use a small lowercase letter, for example, B, and we can use that as the name of the line. And so we could just call this line line B. However, we don't always have these lowercase letters labeled on our line. So when that's the case, we actually just have to pick out a few points that are on a line, and we can use any of those 2 points to create a name for our line. So again, if you don't have this lowercase letter labeling your line, you can just choose any 2 points that are on the line and use that to put a name on your line. So for example, here I can just call this line BC because B and C are both points that lie on our line. And I could have chosen A and C or C and B. It doesn't really matter which 2 points I choose or in what particular order you put the letters, as long as you're just choosing 2 points that are on the line. And then the last thing you need to watch out for is notice how over B and C I put the small line symbol with the arrows on the end points. You want to make sure you include those arrows on the ends to show that you are talking about a line. So the next term that we got is the line segments, and we know line segments are just part of lines that do not go on forever, and they actually have the 2 endpoints at the end, so it has a finite length. And when we represent it, it might look a little bit something like this, with 2 points at the ends representing that it actually stops as opposed to a line. And those 2 endpoints could be named after whichever capital letters. For this example, we have X and Y. And to name our segment, we're going to just use the 2 endpoints and then draw a small segment symbol over the 2 letters. And an interesting thing happens when I go ahead and label one more point on this segment, call that point S. We've actually now created a couple smaller segments within segment XY. So we have, for example, segment XS as well as segment SY. And so in general, regardless of what segment you're looking at, you just have to use your 2 endpoints, and the order in which you list the 2 points is not very important. And so then the next geometric figure we're going to look at is a ray. And we know rays are just also parts of lines, but these only have 1 endpoint and they extend forever in one direction. And it might look something a little bit like this. And you want to make sure to include that arrow on one side to denote that the ray keeps going on forever in that one direction. And so the way we name a ray, we're just going to use its endpoint, and we'll call it A for this example. And we're going to find another point that's on the ray, so we can call this second point B. And so similar to naming segments, we're going to use the 2 points that are on our ray, but we're always going to start with the endpoint here. So notice, since A is my endpoint in the diagram, A is the first letter I have to write down. And on top of A and B, you're also going to make the small ray symbol, which is always going to point to the right. Again, the arrow always has to be above the letter that the ray is going towards and starting at the endpoint. And so I could create one more quick ray just for practice, and I can use the points I and J here. And so when I write the notation for it, I'm going to start with I because that's my endpoint, and then J comes next. All right, and the last geometric term we're going to look at is angles. Now we know angles are made up of two rays that share their endpoint, and they look something a little bit like this. And we've seen the different types of angles, and this would be an example of an acute angle, but we aren't going to focus too much on that today. I do want to recall, however, that this common endpoint has a special name, that is the vertex. However, that is just a point like any other one, so we can call it by any capital letter. So I can call that one A, and I can find a couple other points and call them B and C. And what we have formed now is just this angle, which we can then name using the vertex plus any two other directional points on the sides. So we know that our vertex is A, and two directional points, or just 2 points that are on the rays that make up the sides of the angle, could be B and C. You do have to notice, however, that it is very important that you always list the vertex in the middle. That is why my A is the middle letter. And now we can't just say BAC. We also have to use a little symbol to denote an angle, which goes on the left side of your letters, and it just looks like a small acute angle. Now, that's not the only name I could have for this angle in our diagram. I could also name this one angle CAB. As long as you're keeping the vertex in the middle, the other 2 points, the order in which you list those, doesn't really matter. So now that we've talked about the notation for the different geometric figures, let's look at a couple examples where we're actually going to draw diagrams based on a description using that notation. So for part A, it says draw obtuse angle CDE. And so the first thing I'm going to want to think about is, what does an obtuse angle look like? And so there's really no specific shape I'm looking for here, as long as you can kind of represent an obtuse angle as something that's more wide than a right angle or more stretched out. And so now that we have the basic shape of an obtuse angle, we can just label some points on here using the information that they give us. So we know C, D, E are all points on our angle, and most importantly, D, since it is the letter that's in the middle, that's going to be this vertex point. So this point right here, we're going to label it with D. Now, for angles, it doesn't matter which of the other 2 points you label as C or E, so we can just call this one C and our other point E. And so what we have built, I think, is a great example of an obtuse angle. Vertex points D and directional points C and E. And so if we take a look at part B, this is saying ray XY is going to be bisecting segment AB. So maybe I want to start by just drawing segment AB. And since we're talking about segment, AB are both of its endpoints. Now, if you recall from our vocabulary last section, we said bisecting means essentially to cut in half. And so when we say ray XY is bisecting segment AB, we're just going to draw a ray that is essentially cutting segment AB in half. And since our description doesn't really specify where point Y is, we can just label any other point on the ray as Y. And in this diagram, we can now see that ray XY is bisecting segment AB. So the next example says we have to draw a diagram for angle BAC being bisected by ray AD. Notice it doesn't specify what type of angle BAC is, so really you can just draw it however you want. But the really important part is making sure that you label your points on the angle correctly. So since A is the point in the middle, we know that's our vertex. And the other two, it doesn't really matter which one you choose for B and C. But so far, we have shown angle BAC. So now we want to represent it being bisected by ray AD. Now again, bisected, all that means is it's going to essentially cut it in half. And when we're bisecting angles, we're essentially just going to create one more side going through the middle there. And since we're using ray AD, our ray has to start at the same vertex point from the angle, and point D just has to be some other point within that ray. And so our diagram now shows angle BAC being bisected or cut in half by ray AD. And so for our last example, we have angle PQR and angle TQS representing the same angle. So just start by drawing either of those two. And again, it doesn't specify what type of angle it is, so you can draw it as open or closed as you'd like. But if I label angle PQR, again, Q has to be my vertex, but the other two doesn't really matter which one goes where. And now if we want to represent angle TQS as the same angle, I'm going to go ahead and just use the same vertex and just find some other points within those same rays and label them as T and S. And so now our angle PQR is this right here, but TQS is also this exact same angle. And so the high-level questioning for this section is, can you determine 3 distinct geometric descriptions for the diagram below? So for example, if you were describing this figure to a friend, what are 3 different ways using the notation that we just saw in which you could describe what this figure looks like?